So we're going to do 5.6 notes today. This is all about the quadratic formula and the discriminant. So to start off, let's talk about the quadratic formula. Most of you have already heard this before. Actually, all of you should have. It's x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now you can sing it to the tune Pop Goes the Weasel, and that might help you memorize it because you are not going to be given this formula. If you notice, you have opposite of b over 2a. That's what we use to help with graphing standard form of quadratic equations. And what's left is this b squared minus 4ac. The b squared minus 4ac is going to represent the discriminant, which we'll talk about in a second. Okay. Here's the big point of your quadratic equation or discriminant. Okay, must equal 0. Okay, must equal 0. All right, make sure that it has the equation all on one side of the equal sign before you start doing any of this. Okay, so discriminant in general determines the number of roots or solutions in your quadratic equation. Right, so b squared minus 4ac is your discriminant. Okay, there are 4 types of answers or roots or solutions that you will get, right? If you do b squared minus 4ac and you get a perfect square, like 16 or 49 or something like that, right? You're going to get 2 real rational. That means that you're going to get numbers like 3 over 4 or 1 or negative 30 or something like that, okay, as final answers, okay? And I'm going to erase negative 30 just so you don't think that you'll get 3 answers. You get something like that, okay? Any type of rational number. If you get a positive number that is not a perfect square, so something like 5 or 23 or something like that, that's not a perfect square, you're still going to get 2 real numbers, but now you're going to get irrational, okay? And the reason why is because now you have numbers that you can't take a square root of, so your answers will be something like 1 plus or minus the square root of 13 over 3, well, over 6, okay? Something like that, okay? So those are irrational numbers because you have those square roots left over. Then you can also have negative numbers, right? So you can have like a negative 10 or a negative 55, something like that. You can even have a negative 49, right? It's a square, but it's negative. As soon as it's negative, you're going to have 2 imaginary. Okay? And think about it. You're going to have imaginary because you're going to have something underneath the square root that is negative, like negative 3, right? Which means you have to pop an eye out. Then you have 0. Okay? If you have 0, that means that you have 1 real rational. Okay, because you'll get something like 5 plus or minus square root of 0 over 2, right? Well, plus or minus 0 doesn't give you anything, so you just get 5 over 2, okay? Remember, these 2 are giving you answers to problems such as this, where you have 2 solutions, right? This one right here would be if you have something like this, where it doesn't cross the x-intercept or x-axis. Last one would be something like where you touch just one time, right? So those are your 3 different options here, okay? So it says determine the discriminant and determine the number of. So starting with this first one, remember we're talking about b squared minus 4ac. So I'm going to take b, my b value is negative 8, right? If we take negative 8 and square it, we get 6. Right? Then it's minus 4 times a, which is 2, times c, which is 6. Okay. Now I focus on all of this all at once. You don't have to do it this way, but I think about it as negative 4, 2, and 8. So negative 4 times 2 times 8 is 64. So we have 64 minus 64. That obviously is 0. So if we look at our chart, that means that we have 1 real rational. On the next one, we have b squared minus 4 times a, which is negative 1, times c, which is 1. Negative 2 squared is 4. And then again, I'm going to focus on all of this all at once. So we have -4 times -1 times 1, which gives me a +4, so it's going to be +4. And 4 plus 4 is 8. Now 8 is not a perfect square, so we're looking at just the positive number. It gives us 2 real irrational. All right, so what I would do if I were you is try these 3 on your own before you watch me go through them. I am going to go pretty fast, so keep that in mind. So go ahead and pause the video and try these on your own. At this point, you should have had enough time to try it. So let's go through them. On number 3, we would have 8 squared minus 4, -5, -1. If we simplify, we get 4 minus 20, plus 44, which is 2 real irrational because it's positive, but it's not a perfect square. On the next one, we'd have -3 squared minus 4 times 7 times -4. So we have 9 plus 112. If you add those, you get 121, which is a perfect square. So we have 2 real rational. And our last one, 12 squared minus 4 times 4 times 9, which gives you 144 minus 144, which is 0, which gives you 1 real rational. All right, so now that we've had practice with the discriminant, we're going to put it all together and do the quadratic formula. So with the quadratic formula, we have x equals, opposite of b. So b is 6, so opposite of b is -6, plus or minus the square root of b squared, which I'm just going to put what b squared is, which is a positive 36. Remember, it's always going to be positive. Then it's going to be -4 times a, which ends up being 1, times c, which is -16. And then it's all over 2 times a, which again is 1. So if I start cleaning it up, what I do is figure out what the discriminant is, just like we were before. Okay, so if we look at it up here, it's going to be 36, and then if we multiply -4 times 1 times -16, you end up getting 100. Nope, sorry, you end up, I don't know why I do this for it. You end up getting 64. When you add those two together, you get 100. Okay, so now what we really have is negative plus or minus 10 over 2. And we can do separate things. -6 plus 10 divided by 2 and -6 minus 10 divided by 2. So in the first one, we'd get 4 divided by 2, which is 2. And then the second one is -6 divided by 2, which is -6. Looking at number 7. First off, it does not equal 0 yet. We need to make it that one. I'm going to want a positive x. So I'm going to move it over to the left. So we have x squared minus 4x. We're going to move the 4 over to be a positive 4. Now we're set up for x equals opposite of b. B is -4, so we have a positive 4. Plus or minus the square root of b squared, so 16, minus 4 times your a value, which is 1, times your c value, 4, and then it's all over to a. At this point, we now have 4 plus minus the square root of something over 2, right? So something is the determinant, and if we look at it, it would be 16, and then minus 6, which is 0. Essentially, if you add or subtract 0, it goes away. So you're left with x equals 4 over 2, which means x equals. On our last again, we need to get it to equal 0 first. So we have 2x squared plus 25x plus 33 equals 0. And now we can do x equals opposite of b, negative 25, plus or minus the square root of b squared, which 25 squared is 625. I realized on my answer key I wrote 225, which was wrong. So we have 625 minus 4 times 2 times 33, all over 2 times 2. So x equals negative 25 plus or minus. If we clean this up, it would be 625 minus 264, which gives you 361. Um, 361 is actually a perfect square. The square root of 361 is 19. Now, it's not always going to be a perfect square. It might be an imaginary number. If it were negative, it would be imaginary, and you can't go any further. But a lot of times it will be like this. So if we split it, negative 25 plus 19 divided by 4, and negative 25 minus 19 divided by 4. If we do this, we end up getting negative 6 divided by 4 over here, which reduces to 3 halves. And on the other side, if you add them, you get negative 44 divided by 4, which is negative 11.